Welcome back to class, dear student. In this lesson, I am going to take you through smart contracts, explain it for you as the building block of Web3. In previous lessons, as you begin to gear up to your journey as a pro from no code at all to being a pro Web3 developer, through this, we are going to learn about smart contracts, which is what you will be working with a lot as a blockchain developer, smart contract developer, Solidity developer, or whatever language you use. As long as you are dealing with blockchain, you will deal with what is called smart contract. So I will break it down for you, and in this lesson, aim to demystify smart contract for beginners, explain their creation, security, and integral role in the blockchain ecosystem. So we'll understand what smart contracts are, learn how smart contracts contribute to blockchain, explore various smart contract programming language, discover top smart contract blockchains and their respective languages to code on them, then understand benefits of smart contracts in maintaining decentralization, permissionlessness, and trustlessness in Web3. So now I've mentioned before that each of these things I will still discuss. So time for smart contract. You've been hearing smart contract. Smart contract are self-executing smart contract with the terms of the agreement directly written into code. So normally you know what a contract is. It's like you signed a contract. That means contract is an agreement between two people, two organizations, government or individuals, government and organizations, two parties that, okay, I will do this, you will do this, and we will achieve this. Then official written agreement is called a contract. You get employed, sign the contract. You got a job as a freelancer or something. There's a contract. You understand how the payment will be handled, how all those things will be handled. So that's the same concept that was brought to this contract. Being smart means without human interference, it can execute, it can create agreement between one and two people and execute it. So for example, you can have your child and like, okay, if you go to school and get first position, like my daughter now, they just got holiday. I said, okay, with the mom, we are good at, okay, once you want to start your programming for kids, you want to get for a platform for you for kids. So if you can get first to third position, which you usually take between first third, okay, if you can get that, we'll buy you the programming course, which we eventually bought, even though the new school she went to now, they didn't really like give us position because they said parents were fighting about it and things like that. So, but she got a very, very good grade. Now, what about if we decide not to keep to that promise? What will she do? She won't be able to do anything. So now, what about if we can have a trustless platform which will work with the blockchain, and then we can have that to like, okay, this is what we've got. You understand? This is what we've got when smart contracts. You understand? Like, okay, this should execute when our daughter, you understand, auto execute on blockchain. You understand? So this can execute by itself on the blockchain by just giving it some instruction earlier, and then before you know it, it will begin to do those things by itself. It will begin to set those rules we set by itself. Let me try and change this color. Oh, sorry. Border. Yeah. So if we move this, so now imagine this. Now we then execute. Let's now say, okay, for us to be sure that we won't change our mind later, like, I think we'll need that money for other things. Okay, we build a smart contract on the blockchain that, for example, it can connect to the platform where we want to subscribe to. It's like monthly subscription for some time, months, like at least 3 months, 6 months, and 1 year. Okay, subscribe to the next 3 months, you'll be on holiday to learn programming or something like that. Now, she's like, okay, once she is age 6 going to 7 now, yeah, she should be able to get this done, should be able to buy for her. So we want to get something like here. Let's say this is coming from the school, which we call Oracle. It's coming from the school. Then once that comes from the school, you get what I'm doing now. Once that comes from the school, it triggers this to go and execute sorry for that. It triggers this to go and execute this, which, if you remember, all those transactions, smart contracts, you get what I'm saying. So now this will go in there to go and execute for us. You will get the point now, and this gets added to the block. Understand? So what we have written here is, if our daughter age 6 going to 7 do this term exam and score between first to third or good grades, which a lot of our grades was like, I think 80, 90, over 100. So if she scored those, check either position or this grade, then go and execute this. You understand what I'm saying? Trigger this on the blockchain, which we have put money inside, and that money will then get triggered, and straight here it will get activated. You understand what I'm saying? From here, which we then go back and activate what we can call, let's put something different. Yeah. So it will go and activate this, which this is a coding program. You understand what I'm saying? You can see it now. So this one, we call it Oracle, which you will still learn more in future development. We call them Oracle. What they do is to ensure that the blockchain can be connected to real world data of what is happening. So for example, now I need this to come from the school through the Oracle. Like, let's assume they feed that information that, okay, this is what the students call. So the Oracle allow me to get real world data from our classroom, from our school, then activate this at, okay, check. Once the result is out, the results get triggered, check first to third, no. Okay, great, good grade, okay, good. Then it triggers the instruction, which is take the money here, process it through the node and everything, and go and buy this particular something. And I've already put it there that if she doesn't get the good grade, then refund the money back. You understand? That will be, we need to do another one thing here. Then refund the money back. Let's use another object. Yeah. So this, we say refund. Let me try and move them a bit. Yeah, this we now try to refund. So if you have been a kid, which I have been, I know you have been at a point in time, you know, when it comes to money, our parents can be, when it comes to, oh, do this, I will use money to buy this for you, can be less predictable. You understand what I'm saying? And you can hardly hold them responsible, because they will tell you after, you're not eating, you're not doing this, they have used the money for your school fee or this. So especially when it comes to buying extra things for you, maybe shopping or do things they have promised like that. So now, but if we use smart contract, we'll be able to get from the school, send this to the, which will be results, trigger it, send it to the smart contract. It checks, okay, it meets either first to third position, or grade maybe like 75 above. Anything less, that means both check as failed. Then the next thing to do is to refund this. You have to refund this. Let's say A. Then this will refund this back, which is we can call B or whatever. Then when I'm coming, if this is achieved, just want you to grab it. Then we can call this, let's say C. And D. A. So you can see now. So if this trigger everything, this is A, goes to the smart contract, check all those check. Okay, it has met up. Good. Then it forward to C, which execute all those instructions. Get this. Part of it is this code something. Coding will be purchased. Coding purchased. You understand what I'm saying? So the coding will be purchased straight. Sorry. Like that. But in case that failed, then the parent gets refund. You understand? Refund the parent. Yeah. You refund the parent wallet straight, because this has failed. So you refund the parent wallet because this has failed. You understand my point now? Now, the benefit of what I've been trying to let you understand is that the child doesn't need to trust if the parent will just virtually trust, like what? My parents will keep to it. You understand? They may not keep to it because they may say, oh, some things, oh, in school, you need to pay your school fee, you need to do, like, you understand things like that. So, but with this now, you are guaranteed that even if your parents want to, default, they can't again, because they have already programmed this into the smart contract, and it has been programmed that the only way that they can get money out of this smart contract, the only way, no way to withdraw, it has been coded, is if this condition failed, which is either you got first to third position, or you score 70 above. Anything less than 70, first, if you didn't score third, first to third, then next, do you score one between 70 to 100? Good. If you didn't score then your parents will be refunded, then you don't buy it. But if you score it, you are sure, even your parents cannot stop this. Once they have programmed it, you understand what I'm saying? The parents cannot stop it again. I can't stop it for my daughter again, because the mom cannot stop it again, because this has bind it. The moment we have deployed to the smart contract, to the blockchain, we are bound by it. That money is there. The only thing that can give it out back to us is this: if she failed and didn't meet up the terms of the smart contract. So that is why it is called smart contract. That usually you don't need a third party to be there. You don't need human. You don't even need to trust the other person, as long as you can check the code and see that the code, and you see there is no back door there, that in case maybe a day to that time I can still go there you understand, and withdraw. You see a code that says withdraw at any time, that would be a red flag. So that's what a lot of bad actors use in crypto to scam people. So those back doors is what they create, because if that back door wasn't there from the onset, forget it. They can't get it. So that is what the basic of smart contract, and why it's the little build block with blockchain that make Web3 very different from Web2. So I hope I've been able to, I just try to make it as practical as possible. So that's what it's all about. And how contracts, smart contract made and secure, are written in programming and deployed on blockchain. They are secure through blockchain technology. So you already know that blockchain itself is secure. So once it's here, nobody can remove it. That's why once it gets in here, it must be executed. You don't, it must be executed. You get the point at hand. So when you add that trustworthiness of the blockchain with that smart contract, then you get something solid. So the immutability and distributed nature of blockchain provide a secure environment for smart contracts. So contribution of smart contracts to blockchain. Smart contracts extend the basic functionality from mere transaction processing to executing complex business logic. Like Bitcoin, usually just transaction when it started. Before first smart contract blockchain Ethereum, you still learn about the next one, but it's good you learn about smart contract because we talk about it a lot, and that's what you'll be building most in the aspect of the back end of the blockchain for your DApp. So types of smart contracts is Solidity, which is the parent language for Ethereum and other EVM compatible blockchain. Then Rust, used for Solana and other non-EVM like Polkadot. Then other languages, a lot of other blockchain have their own programming languages as well. So some of the top contracts, some of these things, not Solidity, Solana blockchain, Binance, which is now BNB, also use Solidity. I think this is not its a mistake or error there. So Rust, then I think they use C++, Python, then now Solidity through Solana. Oh, sorry, I thought I was talking about Solana, Rust, and some other things. So most of them use multiple something now. So Cardano use Protos, Algorand is it Tail, then Avalanche, Solidity, Tezos, Flow use Cadence, Cosmos, I think Cosmos 1, and things like that. So each smart contract, but when you look at it, a majority of them uses Solidity. That's why learning Solidity, especially as a first smart contract programming language, gives you opportunity over different blockchains compared to limited by if it is Rust or things, and it's even much easier to learn and things like that. So we'll still learn more about that. Then what are the benefits? Smart are essential in maintaining decentralized, permissionless, and trustless nature of blockchain network. They automate processes, reduce reliance on intermediaries, and ensure the integrity of transaction, adhere to the principle code is law. So you can see it as I've explained with my daughter here. So we eventually got it for her. You understand? Even before the result was out, just some days before. But that will not always be at times. Just like, oh, I got some cash I was expecting, didn't fall in. The one I have, I didn't budget it for that. You understand? So, but once you want to make that promise, you have to have that money, put it in the smart contract, and everything will be executed. And I get my money back, maybe be praying. So I don't know, maybe will I be praying later fail so that I can get my money back? You understand? Because without that, you can't get the money back. And she doesn't need to the trustless nature. You can imagine using this to build business and a lot of others, and then you don't deliver work and then be running after people to pay you and things like that. So those are the things smart contract does, which smart contracts are revolutionary aspect of blockchain technology. They offer a secure, efficient, and transparent way to automate and enforce agreement, playing a pivotal role in the Web3 ecosystem. Understanding their fundamental is key to grasping the vast potential of blockchain. So once you understand this now, you now know the rest is now the code, because all these things you are saying must be put in code. That's when you talk about this programming language, you use the programming tools and things like that to be a smart contract developer. So a lot of those are coming up as well in this lesson, other lessons, and then before we move to programming proper. So that's it. If you got any question, God's talk, check other students if there is question below. If it answers your question, please don't repeat. We will delete the question. But if it's not repeated question, then you get answer. Want to add image, all those things, you see where and how to add them and add the link to it. Don't upload them directly. So that's it for this lesson. Remains on first K. Clip the program sweeter and alive. And please always do good to humanity and nature with your knowledge and programming skill, and not evil, to make the world a better place. Peace out.